Okay. As a contestant on a reality TV show, you're brought to the center of a huge desert. You're given an odometer, which you can use to measure distance, a compass, and a calculator, and told that you can collect the keys to a new Lamborghini if you get to them within 1 hour. You're told that you can get to the keys directly by following these displacements. One of them is 32.4 kilometers, 12 degrees east of north, and then go 30 kilometers due south, and you'll get to the keys. So you could follow these directions exactly, but your time is limited and there's really no way you could get there in time. So the challenge is to do a calculation that will get you to the Lamborghini as soon as possible. So one idea is to draw the vectors so that you can get a sense of what the answer is going to look like. It's probably first worth drawing some axes. Let's let this be north, south, this is west, and that's east. And if you don't like those cardinal directions, you could also call this y, you could call this x. Okay. So vector A is 32.4 kilometers, and in the direction 12 degrees east of north, so we have to understand what that means. If you go due north, then it would just say north. If you then go a little bit east of north, that would be in this direction. So the way that this is described is that this angle here is measured with respect to the north, and it's equal to 12.0 degrees. That is to say, this vector east of north means tilting a little bit more east than west. That is vector A. Okay, afterwards, after you've made your displacement A, then you're supposed to go due south. So vector B would look something like this. So you're already getting the sense that it would be much quicker to go directly to the tip of the arrow B than to go through A first. And so that's where supposedly the keys are. And I'll draw this in purple. We'd like to go directly from our starting point to the ending point, following a vector that, for sake of giving it a name, I'll call that vector C. Okay. So the idea is to figure out what that vector C is in terms of the given vectors A and B. Okay. Now realize that whenever you're adding vectors or subtracting vectors or doing most anything with vectors, it's really, really helpful to think about them in terms of their components. They have x components and y components and maybe also z components. And so we can realize that this vector equation actually tells us two equations. Number one is that the x components of C consist of the x components of A and B added together, and likewise the y component of C is given by the y components of A and B added together. So that's really our task, is to figure out what are the x and y components of A and B. We can add them in the appropriate ways, figure out what C is, and then we'll be on our way. So let's zoom in on this vector A to get a better sense of what it looks like. If we zoomed in on A, we'd like to know what its x and y components are, or north and east components, let's say. Whenever you're doing this kind of problem, breaking a vector up into its components, you're ultimately doing a kind of trigonometry that involves right triangles. It may not be clear where the right triangle is until you start to put in some lines, some thin or dashed lines to help you visualize what's going on. What I like to do is put in some dashed lines that go through the arrowhead and the arrow tail, perpendicular and parallel to the axes that you're talking about. In other words, let's put in, just to visualize, some horizontal dashed lines through the tail of the arrow and the head of the arrow, and do it vertically through the tail of the arrow and the head of the arrow. This is almost always where I begin. This is what allows me to see that there is a right triangle hidden inside there. You can identify a right triangle there, there's the right angle, or you could do it here. Realize that this angle is the 12 degrees that we mentioned before, and the components of A are indicated here. AX is the width. It's also the width down here. AY is the height. You can draw it there or there. We're going to focus on this triangle right here with side lengths AX, AY, and the hypotenuse, which is just A. So as a reminder, to figure out whether you use sine or cosine or tangent, it's really important to identify what the adjacent side is and what the opposite side is. So for example, if I was going to compute sine of 12 degrees, well, I could put that in my calculator, but the way it's related to the side lengths of that triangle, the opposite side is AX, the hypotenuse is A, and that's how I can solve for AX. I'll just rearrange this and write it as A times sine of 12 degrees. That is what AX is. Plug in my numbers, 32.4 kilometers. Sine of 12 degrees, you can look this up, 0.2079 to 4 sig figs, and you'd find that this is 6.736 kilometers. That's what AX is. Okay, and we'll need that a little bit later. To figure out what AY is, you follow the same procedure. Instead of sine, it would be cosine, and so I'm just going to write that down. A times cosine of 12 degrees. That's what gives you AY. So 32.4 kilometers times the cosine of 12.0 degrees, that's 0.9781, gives me a value for AY, 31.69, and if you want to keep some extra digits here, 20 kilometers. I'll have to do something similar for BX and BY, but in fact, BX and BY are quite simple because B simply points straight down. So off to the side here, let me draw what's going on with that vector B. There's B. It has no X component. There's no amount of this arrow that points left or right. And it points purely down in the negative Y direction. This tells me the following: BX is 0, BY is simply minus the magnitude of B. In other words, minus 30.0 kilometers. The minus sign indicating that it points down in this picture. All right, now that we have our components, we're ready to add them together to get the components of C, and ultimately that will allow us to get both the magnitude and the direction. So let's do that now. So CX is equal to the X component of A plus the X component of B. The X component of A, we found that out, was 6.736 kilometers. BX was 0, and so that's it as far as we're concerned. CY is the Y component of A plus the Y component of B. We'll add those together. This is 31.6920 kilometers, and then the Y component of B is a negative number, so we put minus 30.0 kilometers, and that gives us 1.69, and I'll put another digit, 2 kilometers. Now that we have the components, getting the rest of this problem done will be quite straightforward. We have a vector C, right? This is representing the direction we would like to walk to get to the keys to this Lamborghini. We'd like to know how far we have to walk, the magnitude of that vector. We also want to know at what angle we have to walk. Let's take stock of what we just figured out. We figured out the X and the Y component. So remember, if you're breaking up a vector into components, do the trick where you send parallel and perpendicular lines through the head and the tail of the arrow that you're trying to decompose. When you get done with that, you'll realize that there is a right triangle hiding inside. This component, from here to here, that's CY. And here, that's CX. And so to get C, you're just getting the hypotenuse of this right triangle. C, being the magnitude of that vector, is just the square root of the sum of the squares. I'll let you work this out. Take the squares of each, add them together, take the square root, and round to 3 sig figs. You should find that this is 6.95 kilometers. That's the magnitude. The last thing to do is figure out at what direction you should be walking. If we measure this angle here, let's call that theta, then we would be measuring theta with respect to the x direction, which remember that's east. So let's work this out. We can, for example, pick any trig function you like. I'll choose tangent. Write tangent in terms of the relevant side lengths, cy and cx. That tells you that the angle theta requires the inverse tangent of cy over cx. In other words, the inverse tangent cy, which was 1.692 kilometers over 6.736 kilometers. Notice that the kilometers must cancel because the argument of that tangent can't have any units. When you work this out, the angle you'll get, 14.10 degrees. I'm going to want to round that to 3 sig figs. The final answer for the direction, theta, is 14.1 degrees in which direction? As defined, if that's north and that's south, and that's east and that's west, and you start going off in this direction, you're measuring that as being north of east. So 14.1 degrees north of east would be the direction you should travel. Travel for 6.95 kilometers, and you'll get to the Keys.